I'm recording a test done for those who are using aircraft radios, airband frequencies. I want to emphasize the importance of speaking louder in your headset or in your microphone, and I will demonstrate by modulating signals or by simulating a weak signals from a bad headset or from a source of sound or audio that is weak when compared to a louder sound, simulating a pilot talking into a microphone that being plugged with saliva or debris or dust, or have the foam, protecting foam on the microphone boom very old, brittle, or foam that is that old that it's sticky and is plugging the microphone element little grill. So it's important to check that part. It's important to do radio checks before you go flying, and maybe have a backup radio to do a radio check between your aircraft radio and your backup radio on a different frequency. You can talk back and forth to yourself and see how your headset, the aircraft headset, sounds. You can test different headsets if you have multiple stations, and you know when you're good to go. And also you get feedback for yourself. You learn that, let's say, one headset has a bad or muffled or quiet microphone. Then you know on that headset you need to talk louder, because you will have hard time talking to other pilots. They need to know your position reporting, and you may annoy the controller when you talk very quietly on the microphone, or even you try to talk louder. The microphone might not be sensitive enough or might be plugged, so your voice doesn't come across the same way. And I'm going to demonstrate by generating some signals. So I have this ICOM radio, which is my backup radio when I have money to go flying, or whatever reasons keeps me on the ground. So this one is a backup radio that has a built-in GPS capabilities, is used or is being designed to be used as a emergency radio in case you get lost, you get some sort of a bearings, you have a VOR, some features that I hope I don't have to use. And this is a 7 watts power when compared to the average portable radio, which are 4 to 5 watts output. Now 7 watts doesn't sound a lot when you compare to 25 watts or 30 watts of the radio in the aircraft. When you use only 7 watts, when is the maximum power, and I'll explain you how this one works in the into the airband frequencies, the frequencies that are being used by the pilots. This is the maximum rated power. That means when the signals are modulated 100%, means you are talking as loud as you can, and the microphone is brand new, the headset wiring are good, so all your sound, all your voice sounds are being maximized by the electrical system, by the circuitry, by the headset microphone, and you get the maximum levels at the radio input. Or including the aircraft radio, you get maximum signals, and then you get maximum power output. When you talk quieter on the airband radios, which are amplitude modulated, means the louder you talk, the higher the power, with limitation. Like I said, when you talk to 100% limitation, 100% modulation, means you talk the loudest the system can take your voice. This radios or the aircraft radio will put out their maximum power. Now, if you talk quieter, you will get less power output. And I'm going to demonstrate using a measuring tool I have here on my desk. Again, on these radios, if you talk quiet, you will get low power. What means low power? You have lower range, but at the same time, also on the receiving side, people will hear you quieter. So it's not only the sound levels, but the range is being limited because these radios put out less power when you talk quieter. And I'm going to demonstrate it. And now in this case I know where the microphone hole, the microphone element in the radio is on the circuitry. The hole is right here. So if I talk right here to the screen, I might not get the same voice level as I'm talking right here. So I need to know where my radio microphone little hole, air hole is located, so I can maximize my voice levels. The same thing with a palm microphone. So I have a bunch of microphones on my desk. Probably it's not important to show you. Let me see if I can grab one just like random. The microphone element on this Motorola is here, and I know that for a fact because the microphone element of that microphone is this guy. And I know where it's located. I do work on all sorts of radio equipment for many years, and I know a lot about these radios. Now I want to simulate that power output. So what I'm going to do, I'm going to talk on this radio while using this old service monitor, and I'm going to key up, and since I'm connected with a cable, nobody can hear me. I'm being shielded. Nobody can hear my radio testing. So now I'm talking. If you look at the power, it's 1.7 watts. You see the 1.74 watts. That means is the carrier. It's just signal, the frequencies that are being broadcasted without a voice. And that's not a lot. 2 watts, it gives you a few kilometers, maybe less. If you're higher up, yeah, you get better range. But now let's talk louder. You see I'm getting 6 watts. If I talk right into that microphone hole, I'm getting 7 watts. 7 watts. 1, 2, 3, 4. That means I maximize my power output, and if I get 7 watts, doesn't mean when compared to the 2 watts earlier, doesn't mean I'm getting 3 times the range. It's a logarithmic function, but I still get a way better range than broadcasting 2 watts only. So that's something to note. When you talk louder, you get more power output out of your airband radio. When compared to the FM radio, like a regular QA radios, walkie-talkies, or even FM broadcasting stations on the mountain that broadcast on your FM band, they have constant power. So if the news anchor or the music comes louder, doesn't mean they broadcast higher power. The power is constant on those type of systems that modulate in frequency. Yeah, so that's about the power output, the importance of talking louder. Now I'm going to demonstrate by broadcasting from my equipment into this radio. So right now I don't see any RX because I set the levels very low. So if I want to open the squelch on this radio, now it's open squelch, that's why I see RX. And I'm going to go one step. So it's still loose squelch, means weak signal can get through, including the interference and electrical noise and all sort of weird sounds from electrical interference. But in this case I don't have anything because I'm using shielded cables, so nothing is sneaking in. And now I'm going to generate some signal. So I got a signal that's very weak. It's a minus 116 dBm, which is a very weak signal. So it's coming through, but since it's no voice or no sound, it's just a hiss. Now I'm going to generate a tone of 1000 hertz. No, let's say 600 hertz. 600. So that's 600 hertz modulated at 30%. So if I go like modulating level is 30%. That means it's a quiet sound. If I go quieter, like a plugged microphone, simulated plugged microphone, you see that hiss is louder than the useful sound. So I still hear the sound. Now I pretend I talk louder. When I talk louder, 60% of the available volume, or I can go 100%. 100. So the sound, the useful sound, the tone, it's a bit louder than the hiss. Of course, when you do broadcast very powerful signals, let me turn it quieter. When you broadcast powerful signal or the station is close by, that hiss is not significant. So even a quiet pilot, let's say a quiet means like a 20% modulation, you just have to turn your radio louder. That's why we call it quiet signal. Is not because it's quiet pilot, but in your, let's say, in your way of thinking, as non-technical person, this is a quiet voice, only 30% modulation. If I leave the signal strong, I simulate that the aircraft is within a couple of miles or within the control zone area. I go, let's say, modulate 100%. Like someone is talking louder, or you have a good microphone, it makes a big difference. Now, again, I'm leaving this one at 100%, and I'm going to reduce the signal level. I'm going to make a very weak signal, like the aircraft is like 30 miles away. Or maybe you want to listen to the 80s and you are around the mountain and you are, let's say, 20 nautical miles away, and you need to listen to 80s. Your airplane moves very, very fast, and your 80s is that weak. It's like that. But 80s is modulated at the right levels. Why? Because they are maintained by the NAV Canada technicians, and they go there with specific tools, and they use specific standards to align those transmitters. And 80s will sound pretty good, even on weak signal. But let's say the pilot, you want to talk to have less than 100%. So now it's 100%. And let's say I'm talking to a pilot the same distance, 20 nautical miles, and I'm going to simulate. See, his voice is quiet, but is even lower than the background noise because of the low signal. So every time when you have a low signal, then the radio is going to make his background sound. So I thought to demonstrate, because I have the ability to demonstrate what's importance of talking loud on your microphone, not only for better range but for better signal clarity. Okay, so let me change the frequency. So higher pitch, like a woman high pitch voice, but still that hiss is still there. So it's because I choose to modulate to talk very quiet. So I'm going to increase. See, I'm going to talk louder or simulate a louder signal. You see, it's louder than the background hiss or the background noise. Thank you. See you later. Happy flying and safe flying. Bye bye.